In this video, you will learn to simplify complex fractions. Now, what is a complex fraction? So what it is it's a fraction where the numerator and or denominator of the fraction has a fraction in it. So it's like a fraction inside of another fraction. And we'll see some examples here in a moment. But as you are simplifying, there are two different approaches in which you can simplify complex fractions. The first method is you can simplify the numerator and denominator separately and then divide. Or you can multiply the numerator and denominator by the least common denominator of all the fractions. So we'll explain what these fractions look like, and we'll show both methods in the following slides. And what we have are 4 examples, each of which will increase in difficulty. So to begin, we have our first complex fraction, where all we have are just regular numbers and fractions. All right, so we have 1 minus 1/3, and then divided by 1/2 minus 1/6. So notice we have a fraction where on the numerator we have a subtraction problem, and the denominator we have another subtraction problem with fractions. So using the first method, we would have to simplify the top first. So we'd have to simplify this up here, and then we would simplify the bottom down here, and then from there we can divide with what we have. So assuming we know how to add and subtract fractions, 1 minus 1/3 would just be 2/3, and then 1/2 minus 1/6. 1/2, remember, is going to be 3/6, so 3/6 minus 1/6 would be 2/6. So what we have is 2/3 divided by 2/6. So it looks really messy the way we have it here, but now that we've simplified the top and the bottom, now we can divide. So notice this division bar right here, this is our fraction bar. We can do division where we have 2/3 divided by 2/6. And division means multiply by the reciprocal. So what we're doing is we're multiplying by 6/2. And then from here, when you multiply, we have 2 times 6, or 12 on the top, 3 times 2, which is 6 on the bottom, and then 12 divided by 6 would equal 2. So this approach was our method 1, where we simplify the top and the bottom first, and then we divided. Now method 2 is where we would find the least common denominator of all the fractions we see. So up here we see 2 fractions, right? Well, 1 is not written as a fraction, but we can think of it like that. We have 1 and 1/3, and then down here we have the 1/2 and 1/6. So looking at all the denominators, we have 3, 2, and 6. So what is the least common multiple, or least common denominator of all 3? That would be the number 6. So assuming we know how to find that value, we can take everything on the top and the bottom and multiply by 6. So basically we're multiplying by 6/6 for top and bottom, which is multiplying by 1, which does not change the original value. It just is going to help us with the simplifying process. So multiply everything by 6. And when you do that, you need to make sure that you distribute the 6 to both terms on the top. So 6 times 1 is 6. 6 times 1/3 is going to be 2, right? 1/3 of 6 is 2. So on the top we have 6 minus 2, and on the bottom 1/2 of 6 is 3, and then 1/6 of 6 would be 1. So what we have is 6 minus 2 over 3 minus 1, which would give us 4/2, which would equal 2. So notice both methods will give us the same solution. And I would argue that typically speaking, method 2 would be the simplest approach. But again, it's kind of preference. So whatever is easiest for you, you can use that method. Now our second example, we are increasing in difficulty, where now we have variables. And here, this is algebra in its finest, because we have literally no numbers in here at all, and you're told to simplify. So using method 1, what you want to do is you want to simplify the top and then simplify the bottom. Well, the bottom's already simplified. It's already written as one fraction. But the numerator up here we can write as one fraction. So that's what we want to do. And to do that, we need a common denominator. So looking at x and y for our denominators, our least common denominator would be x times y. So we're assuming that you know how to find that value. So convert the first fraction into something over x times y. Well, how do we get from the first fraction to this? Well, looking at the denominator, we had x. Now we had to multiply x times a y. So multiply the numerator by a y as well. So we had a y, multiply the top by another y. And then over here, with the second fraction, we had a y in the bottom. Now we have an x times a y. So we had to multiply the bottom by an x, so multiply the top by an x as well. So now we have x times x up here. All right, so what we have is going to be now y squared over xy minus x squared over xy. And we can combine that into one fraction by putting y squared minus x squared over x times y. And that is what we see right here on this left side. And now that we've simplified the numerator by putting into one fraction here on the top, we can now divide. So right here, this is our division bar that we're looking at. So what we have is this top divided by x plus y. So divide by x plus y over xy. So that is what this fraction bar means. And when you divide, remember, that is the same thing as multiplying by the reciprocal. So what we're doing is really taking this numerator up here, times, and then xy over x plus y. All right, so now from here, we can simplify. So notice, first of all, that the xy up here can divide with the xy down here. So we're left with y squared minus x squared on the top over x plus y on the bottom. Now, one last thing. Notice that this numerator is a difference of squares, and that can factor as y minus x times y plus x. So now notice the y plus x right here, that is the same thing as x plus y down here. So those would divide out, and you're left with simply y minus x. So this entire mess up here can be simplified to be just y minus x. Now this was using method 1, and that was where we simplify the numerator and the denominator first, and then we can divide. Method 2, over here, we would look at each denominator. So we have here an x, we have a y, and then we have xy down here. And then we find the least common denominator of all of that. So assuming that we know how to find the least common denominator, we would have our least common denominator to be x times y. All right, because we have x's and y's represented, and they each have 1 at most. So we just take 1 of each, so we have x times y. So what we do is we take this numerator and denominator and multiply both by xy. So multiply the top by xy and the bottom down here by xy, which is what we see typed up down here. And now just remember, when you are multiplying by the parentheses, you need to distribute. So we have xy times y over x, and just in case you can't visualize that, xy times y over x, the x's would cancel. You're left with y times y, or y squared. So that is y squared, and then xy times x over y. We would have the y's would cancel. That gives us x times x, which would be x squared, and the minus sign in between. Do the same thing on the bottom, xy times this x plus y over xy. And when we do that, this xy would cancel with the 1 down here. That leaves us with x plus y. Now notice this is exactly what we had right here at this point with the first method. So all the steps from here are the same, where we can factor. That's a difference of squares. So we get y minus x times y plus x over x plus y. And x plus y and x plus y cancel. And that leaves me with our final answer of y minus x. So either method would work. And typically, I would argue that method 2 would be simpler. And notice this would actually have fewer steps using method 2. Now let's take a look at 2 more examples. This next one, we have negative exponents. Now remember, negative exponents means that we have a fraction. So x to the negative first, that is the same thing as 1 over x. Then x to the negative second power would be 1 over x squared. So what we have is 4 plus 1 over x over 3 plus 2, and then times 1 over x squared, which would give me the 2 on the top, and the x squared would go on the bottom, down in the denominator. So this is what we have. So again, I will show you both methods, and method 2 is probably simpler, but you are welcome to use either. So method 1 would be from this point, we would need to simplify this numerator up here, and also simplify the denominator by putting each into its own fraction, and then we divide after that. So what we need to do basically for the numerator is write the 4 as something over x. So 4 over 1 equals something over x. We'll do 1 times x to get x on the bottom. So times x. So do the same thing on the top, multiply by x. On the top, that gives 4x. So what we want is going to be 4x over x plus 1 over x. This is for the numerator. And that can combine on the top to get 4x plus 1 over x. So that is all for the numerator. And then the denominator, we have 3 plus 2 over x squared. We want to write 3 as something over x squared. So 3 over 1 equals something over x squared. So we have 1 times x squared to get that. So do the same thing on the top. 3 times x squared would give you 3x squared. So what we have is 3x squared over x squared plus 2 over x squared. And that can combine to get 3x squared plus 2 over x squared. So this would be down here in the bottom. So replacing the numerator and denominator with these new fractions, we see everything typed up right over here. And now once we've simplified, we can divide. This is your division bar. So you're dividing by 3x squared plus 2 over x squared, which remember when you divide, that is the same thing as multiplying by the reciprocal. So what we're doing is we're really multiplying this numerator up here by the reciprocal of down here, which would be x squared over 3x squared plus 2. All right, so this here would be our problem. And then notice that the x squared and x would cancel out. You can subtract the exponents 2 minus 1. That gives you x to the first power, which goes on the top. So we have 4x plus 1 times x on the top over 3x squared plus 2. And nothing else really cancels, so what I can do is just simplify the numerator a little more by distributing the x to both terms. That would give us 4x squared plus x on the top. So this here would be our simplified answer. Nothing else could cancel. Now let's show method 2 for solving this. So method 2, we are starting with this right here. So this is our beginning point. And what we want to do is find the least common denominator. So we're going to look here at this x and the x squared. So the two denominators that we see. And the least common denominator of x and x squared would be x squared. So what we do is we take the top up here, multiply by x squared, and the bottom down here, multiply by x squared. And that is what we see typed up. Now we can distribute x squared times 4. That would be 4x squared. So that's 4x squared. X squared times 1 over x. The x squared divided by the x would just give you x to the first power in the numerator. So that gives you x right there. Same thing in the bottom. X squared times 3 is 3x squared. Then x squared times 2 over x squared. You would have the x squareds cancel. So you have 3x squared plus then 2. So this here is actually, again, our final answer. Nothing else can simplify. And notice that is the same thing that we see over here. So both methods work to get the same solution. Now let's take a look at one final example. Here we have this fraction to simplify. Now this one is a little more difficult because we notice that down here the x squared minus 1 can factor. And x squared minus 1 is a difference of squares, so we would have x minus 1 times x plus 1. And we see that all typed up right here. So nothing has changed other than the fact that we have simplified, or I guess factored, the denominator. Now this one, method 1, would work, but this one would be quite a bit more difficult. So we're just going to show you method 2 for this one, where you find the least common denominator. So the denominators we're looking at are here, the x minus 1, and then down here, x minus 1 times x plus 1. Well, to find the least common denominator, we see what factors we have represented. So we have x minus 1s, we have x plus 1s, so we take at least one of each, and we would take more if we see that one of those fractions had more than one. But here they both only have one of each, so our least common denominator would simply be x minus 1 times x plus 1. So this is going to look really messy, what I'm about to show you, but we're basically taking the top up here and then the bottom down here and multiplying each both by the x minus 1 times x plus 1. Alright, so we're doing that for top and bottom. So that's what we see right here, x minus 1 times x plus 1, x minus 1 times x plus 1. Alright, so this one, and by the way, this is the same thing as x squared minus 1, right? We have that right here. So if when we distribute to the 2, just realize that it's the same thing as 2 and then x squared minus 1. Right, x minus 1 times x plus 1 is the same thing as x squared minus 1. So it's going to make it a little simpler for that part. And then that times this other part, the x minus 1 would cancel with x minus 1 down here. You're left with the plus sign, and then x plus 1 times the 1. Alright, so that's the numerator. The denominator, same thing. We have x minus 1 times x plus 1 multiplied by 2 again. So again, x minus 1 times x plus 1 is x squared minus 1. So we have the 2 times x squared minus 1. And then plus, when you distribute to the second term over here, x minus 1 and x plus 1 would cancel with the entire denominator down there. And that leaves us with just the 1. Alright, so this is what we have, and we just want to simplify the numerator and denominator a little bit. So this would be 2x squared minus 2 for the numerator, 2x squared minus 2, and then plus, we have x plus 1 right there. And then in the bottom, we would have 2 x squared minus 2, and then plus the 1 out here. So again, we can simplify a little bit further. This numerator, we have 2x squared. Actually, I'm going to put this over here. So we have 2x squared, and then plus x, and then minus 2 plus 1 would be minus 1. So that's your numerator. And the denominator, we have 2x squared, and then negative 2 plus 1 would be minus 1. Alright, so this is what we have, and just always check to see if anything will cancel, and nothing else would cancel, so this here would be our final solution. And that concludes our lesson for today. We will see you next time.